Every second, thousands of raw HTTP requests flood an enterprise web server. Each packet of data demands an immediate, correctly constructed response. To manage this volume, the Spring MVC framework directs all incoming traffic through a single entry point. This is an implementation of the front controller pattern. In Spring, this role is fulfilled by a specific Java object called the dispatcher servlet. The dispatcher servlet oversees the routing, execution, and rendering of the response, yet it carries out these tasks without containing any business logic of its own. It functions as an orchestrator, avoiding the God-object anti-pattern by delegating every processing step to a chain of strategy interfaces. The journey of a request begins before it reaches the Spring application context. At the network boundary, the request first hits the servlet filter chain. These filters intercept the incoming traffic to handle protocol-level concerns, such as applying character encoding or resolving Spring security authentication credentials. Once the request clears the filter chain, it reaches the dispatcher servlet, specifically entering the doService method. doService prepares the environment. It binds essential context variables, like locale resolvers and theme managers, to the request attribute map, so they are available to later components. With the context set, the servlet invokes doDispatch. This method serves as the mechanical center of the Spring MVC request lifecycle. Separating the servlet filter chain from doDispatch prevents core business logic from being polluted by protocol-level security and formatting rules. Inside doDispatch, the servlet holds a raw URL path, but it does not yet know which controller is supposed to process it. The servlet identifies the correct route by querying the handler mapping interface. A standard implementation, request mapping handler mapping, searches its registry for a matching @request mapping annotation. The mapping returns its findings in a structured payload called a handler execution chain. This chain contains the target method to execute, bundled with a list of handler interceptor objects. The dispatcher servlet triggers the pre-processing step by calling the apply pre-handle method on each interceptor. If any single interceptor returns false, due to an authorization failure, for example, processing stops and the request is rejected. The handler execution chain allows developers to attach cross-cutting concerns, like logging or authentication checks, to specific routes without modifying the underlying controller code. Next, the framework must handle the controller. Because developer-written method signatures vary in their arguments and return types, the dispatcher servlet cannot invoke them directly. The handler adapter interface serves as the structural bridge that shields the servlet from this signature variety. The adapter deserializes the raw HTTP request body into Java objects based on the specific method signature. In the controller execution phase, actual business logic runs, interacting with service layers. When finished, the controller hands its raw data back. The adapter repackages the result into a standardized model in view object, returning it to the dispatcher servlet. This triggers the post-processing step, where the servlet calls post-handle on the interceptors. Since the HTML view has not yet been rendered, interceptors can modify the data inside the model in view payload before it reaches the final stage. The adapter pattern decouples the framework's orchestration from custom code. It allows Spring MVC to execute varied business logic while maintaining a rigid, predictable lifecycle. The dispatcher servlet now holds a logical view name, but it must still locate the physical file on the server. It passes the logical name to the view resolver interface. The view resolver appends configured prefixes and suffixes to find the resource path. A view object then uses the model data to render the final response. API-driven development changes this final rendering step. If a controller method is annotated with @bodyResponse, the framework intentionally bypasses the view resolver. Instead of rendering a template, the handler adapter uses HTTP message converters to serialize the return object directly into JSON, writing it to the HTTP response body. This dual-path strategy allowed Spring MVC to serve server-side rendered templates and JSON APIs using the same underlying architecture. The final step of the lifecycle occurs after the response has been generated. The dispatcher servlet triggers the after completion interceptor hook. This hook is used for cleaning up resources or logging execution metrics, as the response is already on its way to the client. The completed request pipeline reveals the symmetry of the framework. The dispatcher servlet pulses in the center, delegating to specialized tools at the periphery. Spring MVC derives its flexibility from this interface-driven delegation. The division of labor is specific. The dispatcher servlet orchestrates, the handler mapping routes, the handler adapter executes, and the view resolver renders. By isolating these concerns, engineers can swap view technologies or routing logic without modifying the core request pipeline.